Welcome to the next installment in my video lecture series for the managerial economics class. Here I'm going over to chapter 14, Q&As, and of course starting with Q&A 14.1. Suppose that Greg could obtain perfect information so that he could accurately predict whether it will rain far enough before the concert that he could book a band only if needed. How much would he expect to earn knowing that he will eventually have this perfect information, and how much does he gain by having this information? So as a little bit of a review, let's go over what is in the textbook just prior to this. Remember that if it doesn't rain, Greg expects to have a profit, or he's going to get a profit of $15,000 if it doesn't rain. If it does rain, he's expecting to lose $5,000. The reason being is that he's hiring the band, and paying the band $5,000. Again. But if it rains, nobody's going to pay for admission to this outdoor event, and he's going to lose the $5,000 that he pays to the band. And we're given that the probability of rain is 50% and the probability of no rain is 50%. So the expected value of this particular event is just the probability of no rain multiplied by the value or the profits that Greg will generate when there's no rain, plus the probability of rain multiplied by the value or the profits that Greg will have if it actually does rain. So given the information that we had previously, the expected value is going to be 0.5 multiplied by the $15,000 if it doesn't rain, plus 0.5 multiplied by negative $5,000, the loss that Greg will occur if it does rain. And if we multiply that out, we get the expected value is 7,500 minus 2,500, and the expected value is equal to $5,000. So that's with imperfect information. All right. What occurs when we already said in the text that he will get this perfect information, so he will know in advance whether or not it rains, and he will find out far enough in advance that he does not have to book the band. So he's not going to lose the $5,000 if it does rain, because he's going to gain that information with far enough foresight that he will not book the band and not lose the $5,000. So that's what makes this situation different, is the fact that he has enough foresight, he has enough information that he doesn't book the band once he knows that it's actually going to rain. So the probabilities stay the same, and we're going to calculate the expected value the same, except the value when it rains is going to be 0 versus 5,000 for the previous example that we just went over. So the expected value, when he gets perfect information, he's able to get information about whether or not it's going to rain prior to booking the band. So he doesn't lose money when it rains. So the expected value is now 7,500. So what does he gain from this perfect information? What he gains from the perfect information is the difference between the expected value with perfect information and the expected value with imperfect information. So we have that. So with perfect information, the expected value of this event is $7,500, or the expected profit. And with imperfect information, the expected value of this event, or the expected profit, is equal to $5,000. So if we subtract $5,000 from $7,500, the gain from this perfect information is equivalent to $2,500. We move to Q&A 14.2. Suppose that Irma's subjective probability is 9,000 that the stock will be valuable. What is her expected wealth if she buys the stock? What is her expected utility? Does she buy the stock? So remember, previously in the textbook, they went through a similar example. Irma's initial wealth is 40. The stock will be worth 70 if successful. The stock will be worth $10 if unsuccessful. And I just gave a recreation of the diagram that was in your textbook, so we can take a look at the utility of wealth curve for Irma. In particular, what we want to know is what utility she gets what utility she has presently at the $40. So at $40, she has a utility of $120. If she buys the stock and the stock falls to $10, her utility is going to fall to $70. But if the stock does well and goes up to $70, she is going to have a utility of $140. So that's what we have right here. Irma's wealth is equal to 40. Right now, her present state is that she has utility of 120. If the stock goes up to 70, her utility will jump to 140. As the stock falls to 10, her utility is going to be 70. So we have that information. Let's actually calculate the expected value. The expected value is just going to be the probability that the stock tanks multiplied by the value of the stock if it tanks, plus the probability that it does well multiplied by the price if it does well. So we have 0.1 multiplied by 10 and 0.9 multiplied by 70. That's 1 plus 63. So the expected value, if she were to purchase the stock, is going to be equal to $64. All right, because we've talked about previously in this textbook, I believe that they were stating that Irma was risk averse. So whenever you're dealing with an individual or a problem stating that the individual is risk averse, we have to take a look at the utility and expected utility of the individual. So the expected utility is just going to be the probability that the stock tanks. And if the stock tanks to 10, the utility she'll generate from $10 is equal to 70, plus we multiply the probability that the stock does well and the utility that will be generated if the stock does well. So the stock does well, it'll jump to $70. That'll generate 140 units of utility for Irma. So if we multiply that through, we have an expected utility of 7 plus 126. The expected utility is equal to 133. And the question is, given this information, should Irma purchase the stock given her subjective probabilities? And the answer is yes. Her expected utility is going to be 133 for that transaction given her expected probabilities, when the present state, the $40 that she has, generates a utility of 120. QandA 14.3. The local government collects a property tax of $20 on Scott's store. If the tax is collected whether or not the store burns, how much fair insurance does Scott buy? If the tax is collected only if the store does not burn, how much fair insurance does Scott buy? So let's take a look. We're really concerned with the after-tax expected value, particularly when the tax is always collected. There's two states of nature. The store can either have no fire or it can be burned down completely by a fire and become worthless. So we know that if there is no fire, the store will be worth $500. Scott is going to have to pay that $20 tax. So his wealth, when there's no fire, is going to be equal to $480. If the store does burn down, the store is worthless. Scott's still responsible for paying that $20 tax. Therefore, his wealth is going to be equal to negative $20. So using this information, we can calculate what the expected value is for the store. We know that there's a 20% chance that the store is going to burn, and Scott's value is going to be equal to $20 if that occurs. And we know that there's an 80% chance that there will be no fire, and that the value of the store, or his wealth, when this occurs, Scott's wealth will be equal to $480 if there is no fire. We multiply through, and we end up getting that the expected value of the store is going to be $380. So the expected value, or the expected wealth of Scott, is going to be equal to $380. What's the after-tax expected value when the tax is only collected with no fire? So we're going to go through a similar scenario, except the only difference here is that when the fire occurs, Scott's wealth is going to be equal to 0, because if the store burns down, it's worthless. But if the store burns down, he doesn't owe any taxes, so his net wealth is going to be equal to 0. And the same scenario is going to occur here. There's going to be an 80% chance that the store doesn't burn, and his wealth will be equal to $500 that the store is worth minus the $20 in taxes. We multiply that through, and we get the expected value of the store. The expected wealth of Scott is going to be equal to $384. So we want to take a look at this, and one of the things that you should know is that when under these scenarios, this has a higher expected value. When there's a higher expected value, there's lower need for insurance for the individual. So he's going to purchase more insurance on this scenario versus the second scenario when he doesn't have to pay taxes on the store if it burns down. So we'll figure out what the premium actually is. And if it was fair insurance, the store is worth $500. He's going to have to pay a premium, and we have to subtract off that $20 for the taxes is going to be equal to $380. So the premium is going to be equal to $100. To determine if this is going to be fair insurance, realize that what's going to occur. What happens if the store doesn't burn? He has a $500 store, less the $100 premium, less the taxes. He's going to have $380. So his wealth is going to be exactly equal to the expected value of the store or the expected value of his wealth. Let's take a look at the other state of nature. If there is a fire, he buys $500 worth of insurance. Subtract the $100 premium and subtract the tax of $20. Again, his wealth is going to be equal to $380, which is exactly equal to the expected value of the store or the expected value of his wealth. So he's going to purchase $500 worth of insurance. Let's see how this changes if it's only collected, the tax is only collected when there's no fire. We'll go through the same procedure here. 500 minus the premium minus 200 is going to be equal to the expected value of 380. So the premium is going to be equal to 960. All right, so let's take a look at this. What's his expected value? If there is no fire, 500 minus 96 minus 20 is going to be 380. So his wealth, when there's no fire, is exactly equal to the expected value of the store. Let's take a look at the important part here. But what occurs is what's going to be the actual insurance. If we add the 384 plus the 96 together, that gives us 480. Under this scenario here, because there is no tax involved when the store burns, that the amount of insurance that Scott purchases is going to be equal to $480 versus the $500 under this scenario.